Hello, and welcome to Advanced Mathematics 1, Unit 2, Part 4, Basic Word Problems. By the end of today's lesson, you'll be able to do the following. Translate phrases into mathematical equations. Solve basic word problems. Solve problems involving consecutive integers. That's just regular consecutive integers and odd and even ones. We'll get into that in a little bit. All right, the main concept for today is as follows. Each mathematical operation can be represented by different words. In subtraction, order matters. It's actually true for division as well, but it doesn't happen that often with division. It's more common with subtraction. Use sentence structure to determine which items the operation applies to. This is basically a lesson in translation, and you have to read very carefully and take each thing in turn. So it is difficult for some people because it's learning to translate words into mathematical phrases. So it's kind of like learning a new language. So let's just bump right into the different phrases. So there's lots of different phrases for different operations. First we have the operation of addition, which the terms can be sum, like the sum of a number and 7, and you would write that as n plus 7 if you're using n as your number. Plus a number plus 6, n plus 6. Increased by is another one, when a number is increased by 5, so n plus 5. And more than, 3 more than a number, 3 plus n. It doesn't matter what order you write that in, you could write it as n plus 3 as well. So you can write it in whatever order you want for plus, because plus doesn't matter what order you do things in. Subtraction, however, is where this gets a little funky. All right, less than. 4 less than a number. You will notice that 4 is first, but when I write the translation, it's n minus 4. This is where most people mess up. Less than is written backwards from the way that you translate it. So the letter always goes first, and the number that is less than it goes behind it. So very, very, very important that you pay attention. Difference is in the normal order. The difference of a number and 2 is n minus 2. Minus is also normal order. A number minus 6 is n minus 6. Decreased by is normal order. A number decreased by 7, n minus 7. Fewer than, 8 fewer than a number is backwards, just like less than. So fewer than and less than are the backwards ones. So very important that you understand that. All right, product is multiplication. A product of a number and 3 would be 3n. Multiplied, a number multiplied by 4, 4n. Times, 9 times a number, 9n. Twice a number is 2n. Of is the funky one. Of also means times. So 1/4 of a number would be 1/4 n. And then we have a couple for division. Quotient. The quotient in a number in 5 would be n divided by 5, and divided when a number is divided by 4, n divided by 4. So there we go. Okay, let's just jump right into our examples. I recommend just reading through the problem first before trying to do anything. So just give it a good read through. 5 times a number is 21 less than twice the opposite of a number. When you see the word is means equals in math. So you need to understand that. So I have something equals something. So the something is 5 times the number. So I'm going to write how that translates. 5 times the number is just 5n. Now it says is 21 less than. So less than is my special one that's backwards. So I will actually start with behind here, which is twice the opposite of a number. So I have this equals. Now, twice the opposite of a number means 2 times the opposite, which is a negative value of the number, is literally what that translates to. And I'm going 21 less than that, so that's subtract 21. So this equation is 5n equals negative 2n minus 21. Now I'm ready to solve it. So I'm just going to add 2n to both sides. and I get 7n equals negative 21. Divide both sides by 7, and I get n equals negative 3. Unfortunately, you really can't check yourself because if you didn't translate correctly to begin with, it's not going to matter. So really, it's important that you translate correctly. You will see in some of the homework, I just have you doing translations just to practice that, because that's really the hardest part of these, is learning how to translate. All right, moving into 2. If the sum of twice a number and negative 12 is multiplied by 2, the result is, here's my is, 11 greater than the opposite of the number. So all this first part, the sum of twice a number and negative 12 is multiplied by 2. So I'm going to read that. The sum of twice a number, so twice a number, the sum of that, and negative 12, that sum is multiplied by 2. So that means that entire sum is multiplied by 2. The result is 11 greater than, so greater than means add, the opposite of the number, so that's negative n. So there we go. That's the translation. You just need to take your time, read it through, and make sure you understand that this was multiplying a sum by something, so I have to put the sum in parentheses. So let's go ahead and distribute it. So 2 times 2n is 4n. Negative 12 times 2 is negative 24. And I'll just copy this as 11 minus n instead of 11 plus negative n. So I'm going to move my n's to the other side. And I get 5n minus 24 equals 11. Add 24 to both sides. And I get 5n equals 35. Divide by 5. And I get n equals 7. So that's my number that I'm looking for. And there we go. All right, now we are going to move into consecutive integer problems. There are 2 types of consecutive integer problems. Ones that involve consecutive integers, which means in order. So like 2, 3, 4 are consecutive integers, and they're all one apart from one another. So the pattern is n plus 1, n plus 2. If there was a third one, it'd be n plus 3. For consecutive even or odd integers, you're talking about even numbers like 2, 4, 6, or odd numbers like 1, 3, 5. Okay, either way, if they're even or they're odd, they are 2 apart from one another. So the pattern is n plus 2, n plus 4, and the next one would be n plus 6. So you need to know that pattern so that you can set up the equations. So my first example, example 3 of this, says find 3 consecutive integers such that twice the sum of the first 2 is 2 less than 3 times the third. So I'm dealing with 3 consecutive integers. So I know my pattern is n plus 1 and n plus 2. So that's my first, my second, and my third. Important to know which one is which. Now I'm going to start reading. Twice the sum, so 2 times the sum, I'm going to put parentheses there, of the first 2 numbers. So the first number is n, and I'm doing a sum of that and the second number, which is n plus 1, is, so that's my equal sign, 2 less than, so I'm going to skip over that, 3 times the third. So I'm multiplying the third integer by 3. And I'm going 2 less than that because of this 2 less than. And there we go. There's our equation. So I can just distribute through here, or I could add first and distribute. It doesn't matter. I generally just distribute. So I go 2 times n, 2 times n, 2 times 1, 3 times n, 3 times 2, and then this minus 2 on the outside. Now I'm going to combine like terms. So I have 4n plus 2 equals 3n plus 4. I'll move my n's over. And I get n plus 2 equals 4. So n, I would subtract 2 from both sides, sorry. Minus 2, minus 2. Sorry, I forgot that step for a second. N is equal to 2. Now it asks you for the consecutive integers. So if n is 2, the next two numbers are 3 and 4. So that's my final answer for that one. All right, example 4. Find 3 consecutive odd integers. So I already know my pattern is n plus 2, and n plus 4. A lot of people want to do 1 and 3 for odds, but they are always 2 apart. Think about your first 3 odd numbers, 1, 3, 5. 3 is 2 away from 1, so that's why it has to be set up this way. So that's my first, my second, and my third. Now it says such that the sum of the first and the third. So I'm going to add the first number to the third number, which is n plus 4. Is, so there's my equals, 7 greater than, I can do that in order, the second decreased by 8. So technically it's this. That's the second decreased by 8, but the parentheses don't matter there because of addition and subtraction rules. So I'm just going to go ahead and combine like terms right now. So I have 2n plus 4 on this side. And on this side, I have n plus 7 plus 2 is 9, minus 8 is 1. Now we'll subtract n from both sides. And I get n plus 4 equals 1. Subtract 4 from both sides. And I get n equals negative 3. There's a good thing, a chance that that's right since it is an odd number, but you have to be careful with negatives. So if negative 3 is the first one, the next one that's 2 more than that is negative 1, and the one that's more than that, 2 more than that is positive 1. So be careful when you're dealing with negatives. All right, let's move on to our final example for today, which involves 4 consecutive odd integers. So I'm going to start by writing my pattern. So odd integers, again, we have n plus 2, then we'd have n plus 4, and then we'd have n plus 6. That's 1, 2, 3, 4. All right? Okay, so now we're going to start this, such that the sum of the first and the fourth. So I got the first is n, the fourth is n plus 6. And I have is, so that's my equals. 25 greater than, so 25 greater than means plus, the opposite of the third. So opposite is negative, the third is n plus 4. So you got to be careful when you do an opposite of one of these that you put that in parentheses always in order to make sure you're taking the opposite of the entire number because it is one thing, n plus 4. So I'm going to go ahead and distribute there and combine like terms over here. So we got 2n plus 6 equals 25 minus n minus 4. If it's okay with you, I'm going to go ahead and actually move my n's next. I know that's kind of out of order, but doesn't really matter in the grand scheme of things. So I have 2n plus n is 3n plus 6, and then I will go ahead and combine my like terms over here. 25 minus 4 is 21. So I just kind of did those steps together just to save myself a little space here. So 21 minus 6 Excuse me for a second while I do some math, is 15. So divide both sides by 3, and I get n equals 5. So again, it's an odd integer, so that's a good sign. So I want 4 of them, so that's the first one. So the next odd would be 7, next would be 9, and the final one would be 11. And there we go. And that is today's lesson, and I will see you next time. Goodbye.